Okay, back to the Dumont. I got a great comment from YouTuber John McFerrin, which I think explains one of the odd behaviors I've been seeing. And that is how when I use this over-the-air ATSC to NTSC converter box, I could tune in a station at 2 points, one of which would be fairly watchable and the other would be terrible looking and a loud buzz. Well, he says that's because they use cheap modulators on these and they don't filter out the lower sideband. So that's what I'm picking up. So when I tune in channel 4, I get good reception somewhere around 4, but I would also get it somewhere around between 2 and 3, and that's the lower sideband, which a commercial broadcast would filter out, which explains why when I would tune in our commercial low-power over-the-air NTSC broadcast, I would only receive that once, around 6. I would not pick it up again somewhere down in here. So I think that takes care of that. As long as I can tune it in good at some point on the dial, that's all that really matters. Now, the other issue is, why do I pick up sound at 2 points close together? And why isn't the best sound coincident with good video? Well, typically that would just mean the audio is out of alignment. I've aligned his audio like 3 times. It's picture perfect. The 2 IF stages are dead on, narrow response, looks exactly like it's supposed to, centered exactly on the IF frequency, and the S-curve looks awesome too. So I was thinking, oh, it could be leaky mica caps because I found one down in here, and there are definitely some in here. This is a discriminator, which I don't have a whole lot of experience with. Most sets I've worked on have ratio detectors. I think the only one I've worked on so far with a discriminator was the RCA 630TS, because they were in a legal feud with Armstrong, who invented FM radio, basically. So I think legally they weren't allowed to use ratio detectors at the time. At least that's my crude understanding of it. Anyways, ratio detectors are a bit simpler to deal with, whereas discriminators are a little finicky. So, anyways, so it uses this tube here, which has, a couple purposes. One, it has dual rectifiers that work with the discriminator, and it actually has a triode in it too, so it's the first audio amp. And then here is a discriminator coil. So, could have some bad mica caps externally, and there's also 2 caps inside, which are not marked, which is delightful. But at least I can check the external ones easily enough. Now, something else that's odd is the tuning indicator does not work as it's supposed to. I've gotten confirmation from other 113 owners, and I've read the owner's manual. One bar should be fixed at about 3/4 height, and the other one, when you're tuned in to the best signal, should line up with it on the bottom. Mine, I've got 1 bar at the minimum deflection when I get the best sound. That's not the right behavior, so I'm thinking, instead of tackling it down at this end, maybe I should start at the indicator and work my way back. So, how is this hooked up? How does this work? Well, look on a schematic. It is over here. So, these 2 guys here are the 2 things that deflect those 2 green bars. One of them is at a fixed bias. It's just grounded. And this also has an effect on the biasing. Now, I've checked that. Should be 3.3K. Mine's closer to 4.3K, which could be an issue. Unfortunately, it's inside the socket. But I know Phil Nelson had to replace his, and he wrote up about how it was done. So it can be done. And basically, you have to pry up this metal cap here, and eventually you can pop this base open. There's, I think, 4 slits around the perimeter here, and then a resistor is buried inside. Now, the other deflection plate, well, we got a capacitor to ground and a resistor in line, so that forms a low-pass RC filter. And if you go around, goes over to the mode switch, which ties it into one end of the volume control. which means it's being fed from the output of the sound discriminator. Let's see, is that true when you're in TV mode? Oh, sorry, it's not going into the volume pot, it's going over to this 100K resistor here, so it goes to one of the elements of the sound discriminator. So what I believe is happening is it's picking off the sound before it's converted, so it's actually picking up the carrier, and then it's going through an RC filter, or rather the rectified carrier. So in other words, it's measuring the strength of the audio carrier. If it was measuring the volume, that would be silly, because as the volume varied, you'd see this thing going up and down. It'd be like a VU meter. So what it's really measuring is the carrier strength. So for some reason, something's out of whack. The carrier and when I get the best sound, I do not have this thing deflecting the way it's supposed to. So I'm going to start working my way back. I'll attempt to replace that resistor, and I've already replaced that cap, checked that resistor, but I haven't checked all this stuff, or at least I didn't mark it off. Now, actually, I know I did check these 100K resistors a couple times while I was troubleshooting this, but the 680, this 47, those are mica caps I have not tested, so I think that's a real good place to start. So check that resistor, check these mica caps. As for why they use this type of tuning indicator where you have one bar fixed and the other one moves, why not the older style with like the pi wedge or the eye that would, like a V that would open and close? Well, by the time this set was made in the early 50s, I don't think those had been made for a few years. The early Dumonts, like my RA113 Clifton, that actually has an analog S meter in it. A year or two later, the RA113 series, like the Dumont Doghouse, the early versions of that did have the old type of pi wedge eye tube, and then they later switched to these. This is a 6AL7, which appears to be the most plentiful, common, easy to obtain eye tube. Little short, stubby tube and an octal base. Loads of them on eBay. Why they have the two elements, I'm not sure. They came out around the same time that FM radio was gaining in popularity, so maybe it had something to do with that. There was some need to have two tuning indicators, or maybe using some type of commercial ham radio gear. Not sure. So I was getting ready to start going through and testing the mica caps done in the audio section here, when I thought I would get out my ohm meter and give the resistors one more check, and looky what I found. This guy right here has got a crack in it. Should be 1,000 ohms, and measures more like 300. So that may be overheating because of some other problem and it caused it to fail and crack. Or perhaps it just failed on its own and the circuitry around it is just fine. What I'm going to do is make the latter assumption and just go ahead and replace that resistor. Also, notice this one's a bit off spec too, so I'm just going to go ahead and replace both of those. I've replaced both of those 1K resistors. I then moved on to testing the mica caps. First checked this big guy over here and it was fine. Now I've moved on to this one, which is grid coupling capacitor right there, C204. Should be 10 microfarad, also known as 10 picofarad. So, not sure what the voltage rating is supposed to be, but generally mica caps are good either to I think 300 or 500 volts are the two industry standards. So this is already leaking on 3 range, and check out 2. So it's not very leaky. The light's flashing slowly, but it is flashing. That's not a good sign. I'm going to try to check capacitance, which is really below the bottom end of this device, which they have 0.000001, so that would be 10 picofarads. So that's where we should get an open eye. If I rotate this around, nothing. There's no reaction from that eye at all. And just by way of comparison, I've already pulled out a modern 10 picofarad mica cap with very small leads because I salvaged this out of something. Let's see how this guy tests. Alright, so this shows an open eye way down here near the bottom of the range. So this device is definitely capable of testing a 10 picofarad cap. That's what I'm trying to demonstrate here. And if I check this for leakage, good. All the way to the end of the range. So I definitely want to replace that cap. I could try using this one and solder some extension leads onto it, I suppose, and save myself $1. But since I'm going to be placing an order anyways, I might as well order one up. But before I do, I will check my stash. When I went through that big box of parts that was donated kindly, I did find a whole bunch of mica caps. Some of the old Domino style, but there's also some newer types in there. And yeah, just might find some of the ones I need in here. So that leaves 2 more to check. Now you might be thinking, why don't I just stop screwing around and replace all the mica caps? Well, I am, at least in the audio section. I'm definitely going to replace these last 2 regardless of how they test. I just want to see. Because I kind of want to use it as a benchmark of what should I do on future projects. I kind of don't want to start shotgunning mica caps. 1, they're a little expensive, and 2, often they are kind of specialized ones that might not be available now, like they might be 1,000 volt or 2,000 volt or an oddball value. So I think going forward I really don't have much choice, but at least in some instances I'm just going to have to test them rather than replacing them. Alright, so this should be 27 picofarad. Well, you know, it's leaky too. And just for the heck of it. Yeah, no capacitance either. Huh. If you were thinking that perhaps maybe these mica caps are only rated for 200 or 300 volts and I'm blowing them out by testing them, and that's why they're leaky, well, check it out. The one I just tested is C279, which is 27 picofarad, rated for 500 volts. And I've measured this, and even when it's on 5, it's not actually 500 volts. It's more like 430 or 440, so I definitely did not exceed the voltage rating of the cap. This next cap should be 47 picofarads. Anybody want to lay odds on whether or not it's any good? Well, let's start checking the capacitance first. And I sort of get some kind of indication, but nothing like a real good cap should be. So I'm sure this one is leaky as well. And it's pretty far off too. It should be 47 picofarads, so it should be somewhere down in here, not way over there. And what the heck, let's check that leakage. Yep, there we go. Obviously not super leaky, but definitely leaky. And there should be one more somewheres in here. Maybe it's this guy down here. Yeah, let's see, a blue. It should be a 680. And that's this guy here, which leads around and then goes over to the eye tube. So I definitely want to check that guy. Yes, this is definitely that 680 picofarad cap. So let's test this guy. Hey, this one might actually test good. And it's just about on 680 on the dial as well. And no leakage, but you know what? I think I'll replace it anyways. So, some of the mystique about Dumonts being super high quality is starting to wear off on me anyways. Now, a couple things to keep in mind. One is that this set is from around 51, 52, which is, sets were just starting to, the quality was starting to drop because the production volume just exploded in the 50s. Like in 46, I think there were something like less than 100,000 TVs made, 47, less than 1 million, but by the time you get to 52, they were making like somewhere between 5 and 10 million sets. So, quality probably dropped off a little bit. And another factor is that this set, I believe, was used a lot. I got this from, well, guys who grew up watching this TV. They were very young when their parents bought it new, and I think they kept using this set for quite some time. That's why it's got a replacement picture tube in it, and all the tubes have been replaced. They clearly stated that all the tubes had been replaced in the not-too-distant past, so they might have been using this set maybe through the 50s, 60s, 70s. I don't know exactly when they might have stopped using it, so all that will wear out the parts. Here's a look at the cabinet again to refresh your memory on what this set actually looks like. So, 17-inch rectangular set from the early 50s. Based on some of the comments I've received, I think there's a little bit of confusion as to what set I'm actually working on. So, this is not what I would call an over-engineered set. It's a fine design, it's well-engineered, but it's not over-engineered. It doesn't have a regulated power supply, it doesn't have a CVT power transformer, it doesn't have a delay relay for the B+. That is the earlier Dumont sets that have crazy stuff like that. Like this, which is my Dumont RA113 Clifton. This is the one I did a video on a while back, where I showed the dual chassis, a ton of tubes, a regulated high voltage power supply. This thing is what I would call over-engineered. Also, it's continuous tuning, but no eye tube. Instead, this has an analog S meter for signal strength. At first, I thought this was just for the AM radio, but now I'm not so sure. So this has an AM radio, and then the continuous dial that goes through the TV channels and FM radio over here. But perhaps this meter also deflects when you're tuning on this side. Time will tell. Don't know when I'll get to it, but I will eventually. I kind of want to savor it because it's probably the rarest, most exotic set in my collection. I'm going through the alignment again, just for the audio though this time around, and I just checked the first stage, which is the coupling of the audio from right up front after the tuner to the first audio stage. And that looked to be just fine as it was before, which makes sense because I didn't change any components in that circuit. Now I'm doing the coupling between the first and second audio stage, where I most definitely swapped out a mica cap and changed some resistors, which would change the operating point of that second tube. And now look at this. This is that 2175 marker. Should be up here, and it should be a more symmetrical response curve. Now the marker is way over here. So that most definitely had an impact, which is exactly what I was hoping to see, that me changing these components did have some impact and would alter the alignment, and now I will tweak it again to get that centered on 2175, and hopefully this will improve the audio. And now look how messed up my S-curve is. that should be the crossover point. It should be symmetrical, so it should be more like bloop. So I will tweak that coil too. Alright, let's see if all that did any good. Oh, and got a few comments about that alignment step that required you to modify a tube, and some guys asked, well, why not just disconnect the wires going to that socket? Well, inside here, now it's not so easy to get at. Two, this tube runs at really high frequencies, and the higher VHF stations, you got a couple hundred megahertz. Moving those wires around affects the tuning. I mean, there's a reason why they have you do this. And finally, it's actually not that uncommon. I have alignment instructions for quite a few sets that request that you do something like this. And think about it, if you have a repair shop, you just make up a few of these and you're good to go. You just keep them and keep reusing and reusing them. So I'll hang on to that one too. Alright, so first off, see about some radio reception.
Also be reimbursed for travel and insurance is not required. Periods affect your life. Visit fibroidstrial.com. That's FIBROIDS.
Still a little bit of an odd response, but it definitely is one point where it's the loudest, which is be right here for this station. Like right there, that seems to be tuned in right. That's for the eye tube. I don't really have an antenna hooked up now, so I'm going to skip that and come back to it when I have a proper antenna. Right now I want to check the TV reception. So the only FM signal it's getting in is just leaking in through the cables here, so the eye tube might not be deflecting much just because the signals that are coming in are so weak. Alright, so now I'm tuning in. Oh, geez, that's right. When you do the alignment, you turn the AGC all the way down. I gotta turn that up a bit. I'm not gonna get any reception. Well, that's weird. The horizontal's out a little. Maybe I inadvertently hit the... Huh. Can't get a horizontal lock now. Oh. A good reason for that. I didn't replace one of the tubes. The sink separator tube. Pop that guy in. And we should magically see the picture sink. Bing. There it goes. And this must be the Thriller episode featuring William Shatner. Alright, so... Alright, that's more like it. So now, when I've got the best sound, clearly, I've got a really sharp picture. As for the eye tube, let's see. Yeah, the eye tube's definitely different now, as I'm tuning around. So now, the left side, that's the one that moves. Remember, the right side stays fixed at about 3/4. The left side used to always be either level or above. Now it actually extends down below. So in other words, I can kind of tune to either side of it. And right when they're dead level, like right there, that's when I've got a good sounding picture. So I think I finally got it. Alright. And remember, I'm using this crappy box. Now if you're wondering why do I keep using this box when I know I've got issues with it, simply because of this. I've used this box on a couple dozen sets now. I know if I can get a decent picture and sound with this box, I'll get a fantastic picture and sound with a nice clean signal source. So I want to call this alignment done, and the only outstanding thing now is this power resistor down in here. If you recall, can-dome resistor down there, 2 sections. One of them was still good, and I'm still using it in there, and the other one I bypassed. I would really like to replace that whole thing. I just didn't have the right value power resistor. But I ended up finding all the mica caps I needed in my stash, so I never did place an order. So I don't want to place an order just for a single power resistor. So I'm going to see what I can cobble together. I'm sure I can find some parallel or series combination that will give me what I want. And then I am going to slide this back into the cabinet and use pattern generator and do all the linearity and height adjustments and all that good stuff. I almost forgot I wanted to check the FM reception as well, so I disconnected the converter box and strung up a 3-foot long straight wire antenna. It'll serve well enough. So here's over the air channel 6, and now you can really see how that left bar moves quite a bit. Right there. So that sounds pretty good. So not so good. Not so good. And good. Alright. And just one point where the sound is good. What about FM radio? Oh, similar deal here too. Not so good. Not so good. And tuned in. Oh, cool. If you hear that high-pitched squealing, that's from this TV. Oh, yeah. Still hear it a bit though, because I don't know if I mentioned this or not. When you put this in radio mode, everything is still running. The sweep circuits, the high voltage, all the tubes are lit up. All it's doing is putting a strong negative bias on the grid to blank out the image. Everything else is still running. So you're wearing everything out when you're just listening to the radio. Oops. Tuning.
spin. Rumpelstiltskin in a haystack. Maybe I need a straight jacket, face facts. I am nuts for real, but I'm okay with that. It's nothing, I'm still friends.
And easy, with your pills delivered to your door in an unmarked package. Call us right now at 1-800-768-3097. That's 1-800-768.
List has never been simpler. Whether you're looking for a fun, dirty Santa present for the office, hilarious.
All right, that is it. That's the end of the dial.